Hello, welcome to the webinar focused on maritime spatial planning and shipping and seaports. My name is Ernest Czermański. I'm a professor of the economy. I'm working at the University of Gdańsk and would like to thank you for joining this video. The aim of the webinar is to make you familiar a little bit with the terminology and scope of the shipping industry, about the segments of shipping market, about the quantitative dimension of the market, and finally about the special requirements of the shipping. Coming to the topic, at the very end, we have to explain you some most important definitions regarding maritime economy in the aspect of maritime transport, because you can find or you will meet some complementary or some alternatively definitions like maritime transport and shipping. Basically, maritime transport is a transportation market segment covering all kinds of services basing on waterborne, or in other words, maritime transport means. This definition covers actually everything what we are doing at sea by carrying cargo, passengers, or making other services and products related to the existing of the sea. Then the shipping is the carriage of goods and passengers by any kind of ship on the oceans or seas. And shipping is in that mean rather a commercial using of the sea, where we commercially based against payment, of course, carry goods or carry passengers from port A to B. And then the third definition is shipping owner or ship owner. These are actually the same words, which are meaning the transport service provider acting on the maritime transport market. But we can also define the shipping owner legally as a maritime carrier who owns a ship or shares a ship. The crucial thing is the service provider offers and performs their services under their own name, under their own firm. And it is not important to own a ship, because a shipping owner can also hire a ship and does not have to own a ship to be a shipping owner. What is a ship? It's a transport mean or waterborne transport mean, or there is an alternative word for the ship as vessel, propelled by engines or sails for navigating on the water, especially large vessels then cannot be carried aboard another as distinguished from a boat. So the academic definition always consists two elements. First of all, this is something what helps us to be afloat, and secondly, should be equipped with any source of energy or power to move the vessel's body in the direction we want to direct the ship. Most cases nowadays are mechanical engines, and then sails are not used so often as in previous centuries. And the last but not least definition is regarding seaports. This is actually a transport node located in the interface between a sea and a land, dedicated for servicing maritime transport means as well as all kinds of land transport means, and for transshipment of the cargo or servicing of passengers with appropriate, of course, infrastructure and equipment for that services on sufficient level. Which means a seaport is a dedicated place equipped with a special infrastructure element like berths, like piers, like terminals, storage places, warehouses, and other working spaces to service three actually elements. First, most important is cargo, which is taken from land transport means or from vessels and is transshipped or stored or is divided into several added value services which are offered in a seaport. like weighting, like forming into the containers or in other transport units, or many other services which are all called as added value services. One have to make you familiar also with other abbreviations which you will very often meet in the business, which is IMO, MARPOL, HELCOM, DWT, GT, and TEU. IMO is the International Maritime Organization, is a unit of United Nations dedicated for all maritime related issues. Previously, it was established to keep the safety and security of the tanker shipping, and nowadays they are caring about all actually issues regarding maritime transportation. And the most important problem is now air pollution, and the IMO is a legislation body on worldwide which is implementing each year several directives and regulations which are improving the shipping against the environmental protection. One of the most important international convention is the MARPOL, Convention on Marine Pollution, which previously has been issued mainly against the oil pollution to the water, but nowadays, especially with the Annex 6, it is dedicated or focused on air pollutions too. And HELCOM, especially for the Baltic Sea region, is the Baltic Marine Environment Protection Commission, also known as the Helsinki Commission, which is a body together with a convention dedicated especially for the Baltic Sea environment and environmental protection against, of course, the shipping and port operations. Most important, but not the only three, there are several ships characteristics, but I would like to explain these three ones. DWT means a deadweight tonnage, which is total weight of a ship, which can the ship weight to be still afloat on a safety and security way. So it is a weight measure. Then GT means a gross tonnage, which means the capacity measure, and the TEU is also capacity measure, but dedicated only for containers capacity of a ship, which means a 20-foot equivalent unit, and one TEU means a space or a slot for one 20-foot container on a ship. The maritime transport and seaport functioning, these both elements are directly described in the ocean-based industries prepared by the OECD. But I would like also to underline that this is not only these two industries, because they are very closely connected to some other industries like maritime and coastal tourism, like maritime equipment, and of course, the most important, shipbuilding and repair. So the connection between some industries are very close and very important, and in total they are giving some kind of part of the maritime economy. And then market segmentation is very crucial to present here, because of the shipping market, a quite global and huge definition, can be divided into two parallel and dichotomic segments. The first one is tramping shipping, and the second one is liner shipping, where the tramping shipping can be divided into three sub-segments, which is conventional tramping or classical tramping, then corporate shipping, and the third one is specialized shipping. Conventional tramping or classical tramping is most common understood tramping in the shipping market and relates to all processes which are done in this segment. Then the corporate shipping, in the opposite, is tramping shipping but organized, dedicated, or in the framework of a one company or one corporation. And then specialized shipping. This is a part of trumping shipping dedicated for one group of a cargo, but still fulfilling all elements or requirements which will be in short described. Then the second segment, the liner shipping, is existing or basing on three different elements. The main or the most common is ocean lines, fulfilled with the second part or sub-segment, the feeder service, and existing somewhere in the vicinity or parallel to the previous two mentioned lines, the short sea shipping, which is connecting directly to different ports on the short distance. In the opposite side, the ocean lines are the global lines connecting continents and connecting main ports, which are called very often hubs. Due to the economic of scale, where the ocean lines are serviced by the biggest ships worldwide and are carrying cargo between actually two different continents or regions, and then deliver it to the final destinations via smaller ports, via feeder ports, basing on feeder services. What is the trumping shipping? This is actually part of maritime transportation based on occasional trips, chartered for each trip separately by separate negotiations and charter party or by time charter. Here we have some several possibilities to charter a ship, but basically the crucial element establishing trumping shipping is the occasional carriage, and each trip is a separate process, is a separate service. What are the most important features, characters describing trumping shipping? Here we are using full vessel loading. It means at the first place is the cargo, and we select a ship with regard to the volume of the cargo, not in the opposite way. That's why we call it a full vessel loading. Then we have irregularity of a shipping activity, because the first process may be from port A to B. Then in the port B, we have found a cargo to another continent, for example, port C. And then in the port C, we are looking for another cargo independently from our preferences. We have to switch to the market conditions and take what the market is offering already at the time. Then if we have full vessel loading, then we have dependency from one forwarder. If the one forwarder resigns of the contract, then the whole process will be, of course, cancelled. Another important element is consensual character of the charter agreement, because we have one ship owner, one forwarder, so they are able to negotiate the charter party and individually to the contract, negotiating all elements, where the most important is, of course, freight rate. As I said already, the freight is calculated by freight rates, which are depending on different criteria like measurement, like capacity, like weight, or ad valorem. It means regarding the value of the cargo, or of course a mix of these criteria. Then another character is market organization by stock exchange. Primarily, we had three such stock exchanges in New York, London, and Tokyo. Now it is moved to the internet. We have a lot of electronic or digital stock exchanges. So this is quite advanced in the digitalization process. And we have also brokerage representation on the market. We have specialized brokers representing ship owners and another ship brokers representing the cargo or the forwarders. As next, the liner shipping. It is a constant organized maritime transit or transportation of small pieces of goods coming from a number of forwarders between an advanced determined ports and terminals, timing on schedule, and pricing by published tariffs. It means we are talking in liner shipping mainly about general cargo, which is carried by a ship or ships in organized liner service, which should be rhythmic and constant to ensure the forwarder the reliability of the service, not only in the perspective of 1, 2 weeks or month, but for the next year, 1 or several years. Of course, if we have then several forwarders, then we have fully independency from one forwarder. If we resign as the ship owner from one forwarder, there will appear for sure another one or several other forwarders aiming to deliver the cargo via our shipping line. Because we are dealing mainly with a number of forwarders, there is no way and no time to negotiate each contract. That's the reason why shipping lines are basing on tariffs, where are described all fares or rates with additional and with discounts, depending on many criteria, again, like the dimension, the length of the cargo or cargo unit, the braid, the height, or the weight, or the value, or mixture of these criteria. That's the reason why we have also adhesivity of a booking agreement. Here we don't have charter parties. Here we are talking about booking agreements, which are best described by the general rule, take it or leave it. It means if you don't agree in advance presented conditions, you don't have to use this shipping line. You can use another one if there any exists, or you have to switch to another transport mode. The market is organized by the one service line. From the practice, actually, this means a monopoly, not a competition, because the shipping market, especially in liner shipping, is a part of transport market where the ship owner intends as much as possible, as fast as possible, to be the only one service provider and to make the service line as the main competition, not to the another shipping owner, but to the another transport mode. On the Baltic Sea, we can observe many such shipping lines which are actually competing with land transportation. The last character is representation by shipping agency. Here we don't have any more ship brokers. Here we have constant agencies which are representing ship owner, and the agency is selling bookings on each ship, each trip to the business. Coming next to the vessels types, I'd like to present to you the vast selection of different and specialized types of cargo to make you familiar with the extent of the market, because we can divide vessel types into the bulk cargo ships, general cargo ships, passenger ships, other vessels, and combination carriers. On the graph, you can see some examples of these 5 general types. And yeah, let's say we can divide each type by subtypes, and also subtypes can be divided into several next level or the lower level types of the ship. In the bulk cargo ships, we can select the dry bulk ships, crude oil ships, oil and products tankers, chemical tankers, and gas carriers. When, for example, gas carriers can be LNG carriers or LPG carriers, or even CO2 carriers in a liquid form. We have many types of ships, and on this table you can see the number of such ships. The data is for 2020, more than 16,000. Then specialized cargo ships, 306. Container ships, we have more than 5,000. Ro-ro cargo ships, almost 1,500. And then bulk carriers, we have more than 12,000. Oil and chemical tankers, almost 14,000. Gas tankers, 2,000. Other tankers, 1,100. Passenger ships, almost 7,500. Offshore vessels, more than 8,000. Service ships, more than 5,500. tugs, which are servicing in seaports, almost 19,000, and fishing vessels, 25,000. In total, they are 117,892 different ships, which are already registered officially and legally servicing in the framework of maritime transport. But I have to extend this information because these are only 1/3 of all ships which are existing and steaming on oceans and seas, because more than 200,000 of such ships illegally are steaming mainly in the South and East Asia, but these are mainly small or very small ships below 500 GT, which is the lowest level or limit, including each ship into the legislation form. In the next table, you will see the gross tonnage of the world fleet divided in the same scheme of ship types presentation. One can state we have more than 1.4 billion deadweight ton of the whole world fleet, regarding, of course, these 117,000 units which are steaming on the worldwide oceans and seas. Basing on the data from Equasis, the spatial distribution of these ships can be observed on the graph. So we can say the dominant area for all ships is East and South Asia, as you can see. We have also a very interesting service, MarineTraffic.com, which is showing us the real movement of each ship. As you can see on the graph, each dot, each point, nevertheless, if red or green or blue or other color, means one ship already existing at sea and reported thanks to the AIS via satellite communication to the general system controlling and monitoring vessels at sea. I would like also to make you a little bit familiar with the crucial elements of infrastructure of maritime transport, because basically there are seas and oceans which are an obvious natural element of infrastructure, and there is no need to establish any artificial one. But I have to state that two crucial elements worldwide and one regional element of the infrastructure is made by the human. It is the Suez Canal, it is the Panama Canal, and for the Baltic Sea region, it is the Kiel Canal connecting North Sea and Baltic Sea. To show you how dense traffic can be on the sea, because in further I will tell you a little bit about the special requirements of the ship. Beforehand, we have to know where the ships are going, which are the most important routes, where is the most dense traffic. And despite of these two previously shown maps with the Suez Canal and the Panama Canal, the most busiest route is the Malacca Strait. This is near the Malaysia Peninsula. On the map, you can see how dense the traffic is. And if we zoom at the South Singapore Strait, we will see thousands of ships at one moment, which are steaming in the vicinity of the Singapore seaport. To finalize a global or a general aspect of the shipping to the maritime spatial planning, I would like to underline in some easy facts, which gives you a very good overview what the scale is presented by the shipping. For example, one biggest container ship can carry 22,000 TEU. It means 20-foot containers at once, of course, which equals 22,000 trucks or 275 block trains, which should depart from one port, for example, or arrive to one part or port in one moment. For example, the biggest dry bulk carrier can take a load of grain, enough for 4 million of people are eating in a whole month. Another interesting fact is the biggest tanker can take fuel or oil, enough for heating middle-sized city for a whole year. And the most expensive ship has cost around 1 billion euro and it was luxury cruiser Oasis of the Sea. Let's move to the Baltic Sea region, which is one of the busiest sub-region for the maritime transport, because we can find at once more than 4,000 ships in 1 second. On the map taken from Helcom, you can see the most important roads which are used by ship owners on the Baltic Sea. And the main conclusion is generally the traffic is between west and east, where from west we can use 2 different roads. The natural one is over the Danish peninsula or Denmark, and the second is via previously mentioned Kiel Canal, and they are coming together between Sweden and Poland into one corridor and going to the St. Petersburg in Russia, but in between they are finishing or ending their roads also in the ports of Poland, Latvia, Lithuania, Estonia, Finland, and North Sweden. On the graph, now you can see the amount of seaports which are existing on the Baltic Sea. Generally, there are 400 of them, which is or equals almost to 10% of all globally summarized number of seaports. From these 400 seaports on the Baltic Sea, 90 are of crucial importance for the economy. And despite of them, the Baltic Sea is lying in 2 TEN-T corridors, which gives the information that the region is really important, not only itself for the region, but also for the whole European Union. Some volumes which we can aggregate, for example, the data for 2018 on the south in the Baltic Sea, there were 1 billion tons turnover in the 1 year. And while in the whole European Union, it was 4 billion tons. So it means our region, which is not huge in regard to the population or in regard to the area, but is very important and equals to 25% of the cargo throughput made in the EU seaports. Then we can observe in the Baltic Sea region yearly increase rate of the shipping by 7 up to 8% on average, which is a double so high result as for other seaports in the western part of European Union. As I said previously, we can observe daily about 4,000 ships on the Baltic Sea, which makes the sea very fragile for the shipping, because this is a quite small internal sea of the Europe, where such huge number of ships make high risk of any kind of events or accidents, especially when we take a closer look into the cargo types which is carried by these ships on the Baltic Sea. I mean here the tankers with oil and oil products going westbound from St. Petersburg, from Ust-Luga, from Klaipeda or from Riga to the western part of Europe or even further to the United States. This is really very fragile part of the shipping and Baltic environment. At the end, I would like to make you familiar with global trends regarding seaports and shipping sector. The first one is constant volume increase. As you imagine, shipping as well as the whole transport market is a complementary element of the economy. So as much as we consume of different goods, the transport sector has to service our demand. And due to the global economic increase, we can observe, of course, a constant volume increase in the shipping sector. As a result of the increase, we can observe also port size increase, mainly due to the vessel's size. I mean here for the depth of the ship, the breadth of the ship, of course, and also the length of the ship. But not only this is related to vessel size, This is also related to the requested capacity of a port, because hull of a ship or a mega ship with, for example, 22,000 TEU at once requires a lot of space in the terminal for receiving all these containers in a few hours, in 1 or 2 days, and then delivering these containers into the hinterland. And the same is in the opposite direction, because to enable fast or as quick as possible loading a container ship with, let's say, 15,000 or 20,000 containers in 1 or 2 days, it has been collected all this volume in previous several days coming from the hinterland. So the required space for storing huge number of containers is also a part of this port size increase. Then the second process inside the increase of ports is a specialization, because each kind of cargo requires specific conditions for the carriage and transshipment. That's the reason why port terminals are specializing in servicing one type or two types of a cargo to be as fast as possible and to be competitive against other terminals located in the vicinity in the same sea region. Then the constant containerization extension. First of all, we can add one impulse for the containerization increase coming from the self-constant volume increase. So each type of cargo is increasing in the shipping, and then we have to add another trend in this aspect. It is containerization process of bulk cargo. Nowadays, we can observe that in containers are carrying some bulk cargoes like coal, like oil products, fuels, chemical liquids, and other which normally or previously were taken by bulk carriers and tankers. Nowadays, they are containerized and are switching to the container shipping segment. Then we have also, and this is very, very important in the Baltic Sea region, a short sea shipping increase on important sea. Because we are trying to, due to the EU transport policy, to shift as much as possible cargo from road to the waterborne transport. And where it is not possible, then we have to switch or to shift to the rail transportation. But basically, using or taking into account our region and the main leg where the shipping is, we can talk about short sea shipping, which is directly connected with short distances, with shipping lines, with constant shipping lines, which are servicing the trade between countries of our region. Another global trend is increasing demand for the space or the area for different activities related to the shipping. First of all, this is concerning the vessels maneuvering. Remembering that the vessels are bigger and bigger since many years. Also, maneuvering with such vessels requires much space. For example, the entrance to the port of Gdynia, previously enabling for ships up to maximum 250 meters length. Now, after some investments, they are fit for receiving vessels by the length of 340 or 320 meters length. But this is connected with a huge investment, mainly due to the hydrogen technology. Then we also can observe port investment, mainly for the infrastructure extension. And the most common way of this investment is to go deep into the sea with the new constructions or with new terminals. This can be observed in the port of Rotterdam, for example, or Wilhelmshaven port in Germany, or in the central port in Gdańsk, or in many, many other cases. Basically, there is no more space, no more willingness to the publicity or society and policy, of course, too, to spend some land areas for the infrastructure of terminals. There is, despite of the higher cost, there is a general trend to move all ports deep into the sea with the artificial terminals, artificial piers, and artificial berths constructed on the water surface. And the last but not least element of the future shipping, which is also impacting the space or the area of the sea, is automation of vessels and production of autonomous vessels. So far, we can observe some specific sea areas are organized in so-called traffic separation schemes, where basically tankers have their own passageway or path to go through the area separately to the another types of cargo ships to avoid any potential accidents. And there is a question whether automated or autonomous vessel would require a third path, a parallel space for steaming to avoid any kind of accidents between these kind of vessels with the normal vessels or with tankers. So all this means that the demand for the space coming from the shipping will be rather increasing, not decreasing. And if we compare this with other users' demand claimed to the regulators, to the government or authorities, there is increasing on importance questions how to compromise all these different requirements, all this growing demand for the space between different sea users. But this is the question which will be in the future asked or analyzed or elaborated, which we actually can answer only by implementing a well-elaborated and consulted maritime special plans. Let me present you one case study where will be observed potential conflict between shipping and any other stakeholders of the sea space and sea sources. Let's take a look on the shipping line operating between Gdynia and Karlskrona. Some assumptions about the case study you can see at the slide. The shipping owner is Stena Line. He's operating with 3 daily operating ships. Seasonally, there is introduced one another ro-ro ship with the frequency of 36 voyages per week. One distance is about 160 nautic mile, and the average service speed is about 17 knots. On the map, you can see 2 different lines. The pink one is telling actually the normal voyage navigation track of the ships. But as you can see, this track avoids a specific gray area which belongs to the military. And this is a kind of polygon or closed area where it's not possible for any kind of ships, despite of navies, of course, to go through this area. The question is, can we agree with the military that in this specific case will be allowed to the shipping line to cross through the military zone? Some research questions which can be set in this case are as follows. Does the route changing affect the voyage costs? This is the first question. Then, can the maritime spatial planning influence the routing of the voyage? Which economic consequences occur when route is changing? Then, can a ship owner independently decide of the routing of the ship, especially in the liner shipping? Then, another question is, which kind of conflicts can occur when shipping line establishing a new one or existing one should be changed? And the last question, can the MSP be the solution for possible space user conflicts solving? On the next slide, you can see some initial data for the computing. Current distance on the presented case study is 32 nautic miles, and the new possible alternative route is shorter distance by 4.4 nautic miles. Assuming the same service speed, it means 70 knots, and average fuel consumption of the ship, which equals to 2.4 tons per hour, and taking a current average bunker price of marine gas oil for the ship, which is mainly used in the Baltic Sea nowadays, it is 550 United States dollars per 1 ton. And daily operational costs, excluding fuel, of course, which is presented above, and this daily cost regards to the whole ship, equals to 18,000 United States dollars, and daily ship depreciation, which also have to be considered in the calculations, equals to 8.5 thousand United States dollars. Now we can calculate some possible savings. If we shorten the distance due to the changing route by the permission of military authorities to pass through the military zone of one ship by saving the distance only by 4.4 nautic miles, we can save 621 kilograms of the MGO. It means we can save a little bit more than 2 tons of CO2. If we recalculate this by the bunker price, it means for one ship, for one voyage, 342 and some cents. But as I said, the case study regards to the shipping line, which means 3 ships are introduced on a daily basis. The 4th one is implemented in the season, mainly this is the summer. So it means savings for only one ship multiplied by this 36 voyages per week, multiplied by 52 weeks in a year. It means on a yearly basis, we can save the distance by more than 8,000 nautic miles, which equals to fuel savings less than 500 tons, which means savings of the CO2 emission about 1,500 tons of CO2 can be recalculated to the cost savings of only fuel by more than $250,000 United States dollars. But why this case I would like to present you? This is not only about the cost. Of course, this is important. You have to know the share of maritime transport costs in the price of a final product you buy in a shop is lying between 1 and 2%. It's not a huge difference, and it's not a huge share. So changing a price by $300 or $500 per one voyage, where we take more than 120 trucks on board and let's say 500 or 800 passengers, makes actually 1 or 2 cents the difference. But as I said, it's not only about the cost. Since some years, we have also the discussion on the emission reduction in the shipping. With the sulfur oxides, which are emitted always when ships steaming on at sea, is somehow solved so far. Baltic Sea and the North Sea and some other areas assigned as a sulfur emission control areas introduced by the MARPOL Convention, with included global cap since 1st of January last year, 2020. We can state that the emission of sulfur oxides is somehow solved. It's not more about issue. Also, the nitrium oxides have been solved somehow by 80% reduction introduced this year by another annex of the MARPOL Convention, which established the Tier 3, so-called level of obligatory NOx reduction for all ships. The main issue nowadays for the shipping from the environmental point of view is the CO2 emission. This is the reason why, despite of costs presented in United States dollars, I've also added the CO2 emission. Which kind of negative consequences can occur by the shipping operation at sea? If we take into account this specific case study, we can see the new road is much closer to the shore side. So it means it can affect the landscape. For some persons, it is important to have a nice view without any ships, any other installations. But for any other, maybe this will be interesting. How can we solve this? So far, we don't know. But we have to take into consideration both opinions. Then, can this nearing of a shipping road affect the air quality? In specific cases, yes. But in other cases, when especially west winds are blowing, this is not the case. Another question, can the military be affected by the shipping route? Basically, yes. If we assume that the shipping line will be allowed to steam daily by 3 ships in both directions, it means 6 passages through the military zones. It means actually huge amount of minutes in which we cannot use the military polygon for any military activities. But the question is, do we really use it? The question should be answered in the consultations, for sure. Then the fishery. Is this rerouting affecting the fishery? Possibly not, but it depends on activity of fisheries, which also should be discussed during public consultations. Can this affect maybe the tourism? Since many years, we have appropriate regulations which allowed to the tourism normally at maximum 2 miles from shore side to use electric boats or motorboats or kites or other kind of water equipment. And in the same time, it is not allowed to come closer for ships to the seaside. It means some technical conflicts has been solved, but maybe for some tourists, it will be not a nice view to see 6 times a day a big ship passing through. Can the shipping rerouting affect the wind energy farms constructions? Assuming that the areas which we nowadays know where has been designed at the Polish maritime zone, we can answer negatively. Note here we have no conflict. And the same question regarding oil and gas extraction platforms, which are very much depending on the existing sources below the subsoil of the seabed. It means in some cases, it is not possible that the shipping rerouting will affect any kind of human activity. But at these times, assuming some huge amount of different human activities at sea, which are performed daily, it has to be consulted with other sea space users or sea resources users. Concluding this case study, of course, each kind of influencing of current shipping routes at sea, but deciding of shifting some corridors for ships, or generating, in specific cases, extending the road, will for sure affect the economical side of the shipping line. Maybe in some cases, this will be measured yearly in thousands of dollars or euro. In other cases, when the distance will be extended by 20 or 50 nautical miles, this will come into the millions of United States dollars. But taking into account this economical aspect, we always have to implement also on the environmental aspects. Please keep in mind each 1 ton of additional maritime fuel consumption causes additional CO2 emission by more than 3 tons for only 1 ton of marine fuel. Thank you very much for watching this video. I hope it has helped a little bit to understand why ships and why seaports are important in the economy and in the maritime spatial planning process. Thank you very much. Bye.